Chapter 6, Section 1 is about slopes and rates of change. By the end of this lesson, you should be able to find rates of change from tables and graphs, and also be able to find the slope. So two vocab words, rates of change and slope. A rate of change is the relationship between two sets of data that are both changing. And the slope is the steepness of a line. Instead of coming up with examples for these, I want you to simply fill in the blanks for both of those equations. So I want you to read through this activity that talks about a side view of a ski lift. Pause the video and answer these 4 questions. Alright, so hopefully your answers match mine. The vertical change for A to B and C to D is both 1. From B to C it goes up a little more, it goes up by 4. So the horizontal change for all of them is over 3 spaces. So when I ask you to find the ratio, A and B have the same ratio, and B to C is a little bigger. So that's your steepest line here. This right here is much steeper than this one and this one here. And it's because this number right here is larger. So a rate of change allows you to see the relationship between two quantities that are changing. If one quantity depends on the other, then the following is true. The rate of change is the change in the dependent variable divided by the independent variable. So we learned about independent and dependent variables way back in Chapter 2, so we'll have to remember that again. So it says for the data at the left is the rate of change for each pair of consecutive days the same. And then what does that rate of change represent? So if we look over here, the cost of renting a computer is based on the number of days, and then it gives us a nice little rental charge. So we got to stop and think about which one's independent, which one's dependent. Remember, independent is what I change, or what you change. So that would be how many days we want to keep the computer. And then based on that, how many days we keep it, this rental charge is dependent. So notice how this says change in the independent and dependent variables. So you want to look at how much is it changing by. So if we go from 60 to 75, it's changing by 15. If we go from 1 to 2, it's changing by 1 day. So the rate of change is 15 over 1 for those 2 days. And then if we look at that for the next set of days, 75 to 90, it's going up 15 again, and day 2 to day 3 is going up by 1. So my rate of change again is 15 divided by 1. And it asks us to do that for all of these. So 90 to 105 and 3 to 4 is still 15 over 1. And 105 to 120, we're going to do 15, and day 4 to day 5 is still over 1. So is the rate of change the same? Yes. All 15 divided by 1. So what does this rate of change represent? Well, in this situation, since we're talking about renting a computer, it means that it costs $15 per day to rent a computer. Now, because we didn't start off at $15, that means that there's some initial charge that they charge you. But right now, we don't care about that. All we're worried about is what is changing. So then that brings us to slope. The slope of a line is its rate of change. So we talk about rate of change first in just anything, but then we're going to focus on lines in this chapter. And the slope that we need to find, hopefully you are remembering, it's rise over run. And remember, when you rise, you are changing stuff on the y-axis. And when you run, you're changing stuff on the x-axis. So it's your vertical change divided by your horizontal change. So to find the slope of these lines, remember that we read everything left to right. So always find the point on the left. And in this case, it's right here. We want to eventually get to the other point. So we need to figure out how much we rise and how much we run. Now, if you always start with a point on the left, you're always going to be running this way, no matter what. So that means that that number will always be positive. Your rise can be positive or negative, depending on what way your line goes. So in this case, if I'm starting down at this first line here, I gotta rise up 1, 2, 3 times to get to my next point. And then I'm going to run over 1, 2, 3, 4, 5 to get over here. So that means this slope is 3/5. That's the steepness of the line. And then this one here, again, we're going to do rise over run. Remember to start with a point on your left. So I'm going to have to go down 1, and we represent that with a negative, and then run over 1, 2, 3, 4, 5, 6. So this slope is negative. Always stop and make sure that makes sense. This line is going up as we move from left to right, so it makes sense that we get a positive number here. This line is going down as we move from left to right, so it makes sense that we have a negative. Now you're not always given a graph, so we needed to come up with an algebraic way to find slope. And what we're going to do is use that rise over run, but when you're given points. So let's say I just give you 2 points. We're going to call it x1 and y1 because this is my first point, so it's my first x value, my second y value. Or my first x value and my first y value. And then I'll give you another point, and we'll call this x2, y2 because it's my second x and my second y. And to find the slope, you're going to find the change in your y values. And to do that, we subtract, and you find the change in your x values. And again, to do that, we subtract. Now, it doesn't matter what point you call point 1 and what point you call point 2, as long as in your slope formula, those guys on top and bottom come from the same point. So if you notice, both of these first ones come from my second point, and both of these second ones come from my first point. And again, it doesn't matter which one you make point 1 and which one you make point 2. Now remember, we can also write slope as change in y divided by change in x. And remember that little triangle means change in. So let's find the slope. y2 minus y1 over x2 minus x1. So then we gotta label things. Let's make this point 1. So this will be x1, this will be y1. Let's make this point 2. And the only reason we're doing that is because that's the order the problem gave it to us in. So I'm going to take my second y value, which is 7, and subtract my first y value, which is 5. And I'm going to divide that by my second x value minus my first x value. And then we just have to simplify. So 7 minus 5 gives me 2, 4 minus 2 gives me 2, and if we simplify that, we get a slope of 1. So remember, we can turn anything into a fraction. So if we were looking at a graph of this, I would rise up 1, and I would run right 1. And that would give me that slope of 1. So let's try the next one. Again, let's label these x1, y1, then x2, y2. When we plug it in, we do negative 2 minus 4 on the top. There's my rise part. And then my run is 3 minus a negative 1. Now you got to be really careful with your signs here. If you have negative 2 and you take away 4 more, you're going to end up with negative 6. And down here, if you subtract a negative, you're really adding. So we're going to end up with 4. And then we like to simplify our fractions. So 2 goes into both of these. So this gives us a slope of negative 3/2. So remember, that means I would go down 3 and I would go right 2 if I was graphing this. And that's it. So, can you find rates of change from tables and graphs? Here's a graph for you to do on your own because we did a table together. And then I want you to find the slope between these 2 sets of points and then these 2 sets of points. And we will talk about this all tomorrow. Have a good night.